Okay, this is the notes for section 3.6, proportional relationships. We're going to fold it inward like this. Again, this is 3.6, proportional relationships. So we're going to look at what is proportional and what is non-proportional relationships. And this is actually just direct variation all over again. We can tell that something is proportional when the b is 0 or it goes through the point 0, 0. So if you'll highlight that for me. It is proportional when it goes through the 0, 0 or b is 0. So I'm going to underline it here. That's what that means. And is of the form y is equal to km when the relationship is proportional. What does that mean? That means that k is like our m. So k is m. Right here, when you have a situation like this where I want you to fill in a table, you can do it in your calculator. You go to y equals, and you put in the equation that you have, which is 3x. You hit second and then graph. It goes to a table of values, and we just start putting in the values. At -2, it says it's -6, -1, -3, 0, 0, 1, 3, and 2, 6. So just like I highlighted up here, knowing that it goes through the 0, 0 means it is proportional. The reason that we call these proportionals is because of this proportion that we actually have to solve for. You can't choose any 2 points. I'm going to choose this one as your x1 and y1, making it your first point. And this will be your x2 and y2, making it your second point. Here what we do is just substitute in the values for this ratio. 1 and 2. And then it wants y1, which is 3, and y2, which is 6. When you reduce this fraction on the right-hand side, it does equal 1/2. If you are not really good at reducing fractions, what we can do is just get a decimal approximation. And we did this when we were looking at proportions. The section on proportions, we just said that this is one method to check if a proportion is equal. So 1 divided by 2 is 0.5, giving me a decimal. And then you check the other side, 3 divided by 6. So most of you will know that the 3/6 is the same thing as 1/2. But in case you don't know, you can always put it in your calculator. Gets 0.5, and this is what makes it proportional. It is proportional. So the ways to identify, the b is 0. It goes through the 0, 0. And it actually has a proportion when it comes to the values on the table. Let's graph. The -2, -6 doesn't fit, so I'm going to go to -1, -3. 0, 0. 1, 3. And 2, 6 doesn't fit either. Remember what I've asked you to do is make sure that the points touch the ruler first before you draw the line. I want the line to go through the points and the arrowheads at the end. So the last way to identify that this is proportional is that if it goes through the origin or the 0, 0 on the graph. So it's just like direct variation. So let's take a look at it when it's not proportional, non-proportional relationships. If the ratio of x values is different than the ratio of y values from selected order pairs on the line, then the equation is non-proportional. So like I mentioned before, you can select any order pairs. that you would want. All right, so we have an equation. This is the first way that we can identify that this is non-proportional. So what I'm going to do to make the difference between the proportional side and the non-proportional side is that I'm going to mark it out like this. That's what makes it non-proportional. We already know, but let's take a look at our table of values. To get the table of values again, we're going to go to the y equals and say 2x minus 1, and then hit second graph and go to the table. At the negative 2, it says negative 5. At the negative 1, it's negative 3. 0, negative 1. 1, 1. 2, 3. This right here is enough to tell you that it does not go through the 0, 0. Like I mentioned before, to make the difference between proportional and non-proportional, I'm just going to mark it out. I also mentioned that you could choose any points to check the proportion. So I'm going to select these first two. This would be my x1 and my y1 because they're my first point. This is x2 and this is y2 because they're my second point. So I'm going to write negative 2 divided by negative 1 and negative 5 divided by negative 3. Some of you will be able to tell that these don't reduce correctly, but in case you don't, you can always use your calculator. Negative 2 divided by negative 1 gives you 2. And that's not equal to 5 divided by 3, or 1.6 repeating. Making this equation non-proportional. Let's graph. Negative 2, negative 5. Negative 1, negative 3. Zero, negative 1. 1, 1. 2, 3. Okay, make sure that your points actually touch the ruler before you graph the line. Put arrowheads at the end. And the last way to identify that something is non-proportional is that it doesn't go through the origin at the y-intercept, making this whole line non-proportional. All right, take a look inside. It says complete each table of values, then write the equation in function notation for each relation. So let's take a look at this pattern. From here to here, I would have to add 5. That means that to keep going from here to here, I would have to add 5 again. Negative 5 plus 5, in case you're not sure how to do this. Negative 5 plus 5 is 0. And then plus 5 is a positive 5. We also have to make sure that we know the changes of x. From here to here, I would have to add 1. From here to here, I'm still adding 1. And this is why the arithmetic sequence matters, to make sure that we have a correct pattern, plus 1. And don't forget, your slope was the changes of y over the changes of x. So that means the y's go on top. We have the equation y is equal to m, which is slope, changes of y, 5, over the changes of x, 1, x, and then plus b. How can we identify the plus b? It's where the x is 0. That's your y-intercept. So I'm going to say this part again. What we did was write the equation in the form y is equal to mx plus b. The changes of the y over the changes of the x gives you the m. And the b is by the x value equals 0. B is where x equals 0. So we're looking at the y value. Write the equation, and function notation is when we write that fancy f of x. We don't ever need to write 5 divided by 1. We could just write 5x, and we don't need to write the plus 0. But we know by it crossing the 0, 0, the intercept being 0, that this was proportional. Let's try it again. From here to here, we have to subtract 2. So that means that from here to here, I also have to subtract 2, which gives me negative 4. From here to here, I have to subtract 2, giving me negative 6. Y is equal to the changes of y, which is negative 2. But now I need the changes of x. And this is why this is important. From here to here, I had to add 2. So from here to here, I also added 2. And from here to here, I added 2. That means that the changes of x were 2, a positive 2. X, and then I'm looking for that y-intercept. That's where the x is 0. Looking for my y value, so I'm going to put big old eyeballs right here. Look, you're looking for this one. 0. It wants it in function notation, so we're going to write our fancy x. We can reduce that fraction to a negative 1, which means I only have to write a negative x. And I don't have to write the plus 0. But this is still proportional. It does not tell us to indicate whether the function was proportional or not. I just want to make sure that we go over the vocabulary. All right, so from here to here, we had to add 1.5. So we're going to add 1.5, giving us a positive 1.5. And then from here to here, we're going to add 1.5 again, giving you 3. It's going to fill the table, complete the table was one of our tasks. And then we have to look at the changes of x. Negative 3 to 0 is a plus 3. 0 to 3 is a plus 3. 3 to 6 is a plus 3. Our formula was y is equal to the changes of y, 1.5, divided by the changes of x, 3, x, and then what am I looking for? Very good. The y value at the x, at the y-intercept, which x equals 0. And that would be plus 0. To write it in function notation, we write it as f of x is equal to, make sure you always simplify your fractions. 1.5 divided by 3 is 0.5. You can write it as a fraction, math, enter, 1/2. Don't forget the fraction in a slope is an action. That's why we wouldn't want it as a decimal, but you can write it as a decimal if you want. Making this one proportional. All right, the next one, we're going to add 1. Add 1 makes 5. Add 1 makes 6. Over here, we're going to add 1. We're adding 1 each time. Our equation will be y is equal to 1, the changes of y, over the changes of x, which is 1, x. And then we're looking for this x equals 0 value. And we write down this one right here. This is what we're going to write down, plus 5. This is enough to know that this is non-proportional. But to write it in function notation, we actually don't need to write the 1 over 1. We have y is equal to x plus 5. Oh, function notation. Sorry. That's f of x.